Hi everybody, this is video 2, which is about transforming data, and I'm going to warn you that this topic is a little bit more difficult than the topic from our first video, so you're going to have to pay really close attention. So what this is about is sometimes we want to take an entire data set and transform it. By that I mean we want to take each individual value and perform some kind of operation, or maybe multiple operations, on each value. And we want to be able to analyze the way that that changes our distribution. For example, let's say I gave an AP practice exam, and you know on the AP exam scores go from 1 to 5. And let's say the average score was 3 with a standard deviation of 1.5. I want to make this into a test score, so I decide to convert these scores to the 100-point scale by multiplying each score by 20. That means a 1 becomes 20%, a 2 becomes 40%, and all the way up to 5 becomes 5 becomes 100%. And I want to know what is my new average score and what will the new standard deviation be. So to see how that transformation would affect our summary statistics, our mean and our standard deviation, we're going to work out a really simple example. Let's say I just had 5 students, and one of them got a 1, one of them got a 2, one of them got a 3, one of them got a 4, and one of them got a 5. Okay? I want to start by confirming that this does have the mean and standard deviation that I had on the previous slide. So I'm going to get out my calculator, and I'm going to enter this data set, this very simple 1, 2, 3, 4, 5 data set. So we know that we hit Stat, Edit, and this brings me to my list, and I'm going to put in 1, 2, 3, 4, and 5. And to get the mean and standard deviation, I need to do one variable statistics. So I hit the Stat button, go over to Calc, and do one variable stats. Since I just want list 1, I don't need to enter anything here, so I can just hit enter again. And I see that indeed my mean, my x bar right here, is 3 with a standard deviation, SX, of 1.58. So it's close enough to what we had on the previous slide. So I'm going to fill that in here. My old mean was 3 with a standard deviation of 1.58. Let's see what our transformed data would look like. If we multiplied each person's score by 20, then a 1 would be 20, 2 would be a 40%, 3 would be a 60%, 4 would be an 80%, and 5 would be 100%. So let's go back to the calculator and see what the mean and standard deviation of this transformed data set would be. I'm going to go back into my lists, and this time I'm going to go over to list 2 and enter in this transformed data. 20, 40, 60, 80, and 100. Now when I do one variable statistics, if I just hit enter here, it's going to perform this on list 1, but I want list 2. So I can hit second list 2, and it's going to give me the one variable stats for list 2. When I look at this, I have a mean of 60 right here and a standard deviation of 31.62. So a mean of 60 and a standard deviation of 31.62. When I multiplied my individual values by 20, it looks like my mean was multiplied by 20. And my standard deviation, I can use my calculator to confirm, 1.58 times 20 does give me 31.6. So if I take every single data point and multiply by some value, the mean gets multiplied by that value and the standard deviation gets multiplied by that value as well. What happens if I'm not multiplying though? What if instead I decide to take each student's score and add 5 points to it? Now I can count it as a 10-point quiz grade. So we still have our same old data set, 1, 2, 3, 4, 5. I still have my same 5 students. And so they still have the same mean and standard deviation. The average score is a 3 with a standard deviation of 1.58. But instead, I'm going to add 5 points to each. So the student who got a 1 now gets a 6 out of 10 quiz. The student who got a 2 gets a 7. The student who got a 3 gets an 8, 9, and 10. Now I want you to pause the video for just a second and try to predict what the transformed mean and transformed standard deviation will be. Okay, let's test and see if your prediction was correct. I'm going to grab my calculator, and now I'm going to go over to list 3 and enter these new scores. 6, 7, 8, 9, 10. If you missed that, you're just going to go to Stat, Edit, over to list 3, and enter those new 5 scores. Now we need to do one variable statistics, so I do stat, calc, one variable stats, and if I hit enter, it's going to do list 1, and I don't want that. I need to hit second 3, so it'll perform these operations on the third list. I hit enter, and I see that my new mean score is an 8. Is that what you predicted? We had the old mean, and we added 5, just like what we did to the data set. We added 5 to each point, so the new mean is increased by 5. But look at the transformed standard deviation, 1.58. What happened to the standard deviation? Nothing. The reason for that is I added the same amount to each value. Standard deviation measures spread, and these 5 numbers are not any more spread out than these first 5. So I'm going to try and summarize what we just discovered there. We are learning about linear transformations, which means we are taking each data point, that's x old, and multiplying by a constant or adding a constant or maybe doing both in order to get our new value. When we have a B term, we are rescaling. That means we are multiplying every single value by the same thing. When we do that, measures of center and spread are both multiplied by that same value B. So that was like when we multiplied test scores by 20. The mean got multiplied by 20, the median would have gotten multiplied by 20, the standard deviation got multiplied by 20, the IQR would have been multiplied by 20, all of them. Multiplying affects everything. When we have an A term, when we have an added constant, that's called recentering. When we do that, measures of center are affected. The mean and median get added by that same amount. So do the individual quartiles. Q1 gets added by that same amount. Q3 is increased by that same amount because Q1 and Q3 are like actual data points, and each data point is added by that value. However, measures of spread are not affected by adding a term. Standard deviation will stay the same. IQR will stay the same. I'd like to finish this with a few examples. We're going to identify which statistics, and I want you to do this for mean, median, the individual quartiles like Q1 and Q3, the IQR and standard deviation will be affected by the following transformations. So the first is giving everyone a 10-point curve on a test. I take each person's score and I add 10 points to it. Well, that's a recentering example. We are adding a constant. So the mean will be 10 points higher. The median will be 10 points higher. The individual quartiles will be 10 points higher because the quartiles themselves don't measure spread. However, IQR and standard deviation will not be affected. They will stay the same because our data is not getting any more spread out, it's just moving up. Now, second example, let's say instead I multiply everyone's test by 1.2. It's a different kind of curve. Since we are multiplying, this is a rescaling example. This is going to affect everything. The mean is going to be multiplied by 1.2. The median is going to be multiplied by 1.2. The quartiles are going to be multiplied by 1.2. The interquartile range, the standard deviation, everything gets multiplied by 1.2 when I'm multiplying. Last example, a little bit more difficult. We are converting from Celsius to Fahrenheit, and here's the equation for how to do that. You take the temperature in Celsius, you multiply by 9/5, and you add 32. We are doing both here. We are rescaling with the 9/5, and we are recentering with the plus 32. Since I have this multiplier term, I know that everything's going to be affected because I am multiplying, but not everything's going to be affected equally. For the mean, the new mean is going to be affected by both. So it's going to be 9/5 times the old mean plus 32. Because multiplying and adding both affect the mean. Same thing with the median. It's going to be 9/5 times the old median plus 32. And that's going to be the same for the quartiles as well. The quartiles are going to be 9/5 times the old quartiles plus 32. However, when I look at the IQR or when I look at the standard deviation, it's not going to be like that. Because remember, this additive term right here does not affect the measures of spread. So for the standard deviation is going to be 9/5 times the old standard deviation, because that multiplier does affect the spread, and that's it. And the IQR, the interquartile range, is going to be 9/5 times the old IQR. And that's it. Okay, that's the end of video 2. Goodbye for now. I will see you in class, and please answer the questions that follow this video.